Hello viewers, in the previous programs we have discussed the very basic electronic components such as resistors, capacitors, transistors, diodes and UJTs. In this program we are going to discuss a very important class of components called the thyristor. Here some of the thyristors have been brought for the purpose of demonstration. Now, thyristor is a 4-layer semiconductor device and it is very much used in the field of power electronics. Since it is a family, thyristor family we can say, it is obvious that there are so many members in this family. Some of them are the silicon control rectifier, the Diac, the Triac, the LASCR known as light activated silicon control rectifier, PUT programmable unijunction transistor and so on. You can have such silicon unilateral switch, silicon bilateral switch, and the latest one is of course known as the GTO, gate turn off thyristor. Now before we go in detail, I would like to tell you that out of these the first three form a very important class of thyristors and we are going to discuss about these three in this program. Now let us see what is an SCR. SCR is a 4-layer semiconductor device as I have already told you. So the layer diagram can be drawn like this: P, N, P, N. 3 terminals are there. The first terminal is coming out from the P layer, which is known as anode. The second one is coming from the N layer, which is cathode, and there is a third terminal coming out from P layer. It is known as the gate. So the terminals are anode, cathode and gate. In the earlier case of diode, we found that it works like a rectifier. This particular device, silicon control rectifier, is also a kind of rectifier, but a word controlled is also there. That means this rectifier not only rectifies, it gives a controlled rectifier output. That is why this third terminal is there, which is gate, and it is meant for control. Now here it is very important to know the terminals. That means identification of the terminals is very, very important: anode, cathode and gate. Now if I look here, you will find that there are 3 classes of SCRs I have shown. Number 1 is this class, 4 of them. Number 2 is these 2, and there is another class. This is the third type of SCRs. You will find that this class of SCRs, this looks like a power transistor, isn't it? This looks like a power transistor. Both of these are known as the metal pack SCRs, and these two look like power diodes. They are also metal pack, but this is a different class of SCR, and you will find that these are plastic case type. So I will explain you how to find out the terminals. There is a universal method, standard method we can say, to find out the terminals of an SCR. Now first of all, let me explain this type, which looks like a power transistor. If you see, its shape is something like this, and earlier also in case of power transistor you had seen, if I draw this line here, I draw it like this, you will find that there are 2 terminals, okay, these are the two extreme holes. Now, if I see it minutely, you will find that this from this center, one of the holes is nearer and the other hole is at a larger distance. Again, you have to keep this in your mind, and this is the one which I would like to show you again. Look here, this metal body SCR has to be kept like this. You see, if I keep it like this, from this center to this hole, the distance is more than from this center to this hole, and the two terminals are coming out. What you have to do is, you have to place it like this, so that the two terminals are facing you, and the more distance should be at your right, the lesser distance should be at your left. In that position, the bottom terminal will indicate gate and the top terminal will indicate cathode, and of course the body is always anode. If I see it here, this is the body, body is always anode, the bottom terminal is always gate and the top terminal is cathode. So, this is a universal method of finding out the terminals of a metal pack SCR. Similarly, you have these SCRs also, same type, and you can find out the terminals in the same manner, but it is definitely of lower rating. This is of higher rating, this is of lower rating. Now, you have another type of metal SCR, these two. You remember, in case of diodes, you had metal power diodes. It is also like that, but you have 3 terminals here, and there is another terminal. It is like this. Again, in this case, you will find that the body is always anode. Body is always anode. So, if I look here, this is the body, this is always anode. The other terminal, this one is cathode, and the smaller terminal is gate. The body is anode, this terminal is cathode, and this is gate. Suppose this is the body, so this is anode, this is cathode, and this is gate. So, in metal pack SCRs, you can always find out in which way the terminals are, which is anode, which is cathode, which is gate. Now, coming to the plastic pack, let us see. The plastic pack looks like this. And the terminals are coming out. There are always 3 terminals in plastic pack. You have to see it like this, that if you see it here, there is a printed part and there is, if I can show it like this, it looks like this. You have to hold it like this. The printed part should be in the front and the terminals are like this, 1, 2, 3. So, if you go clockwise, this will be G, this will be A, this will be K, gate, anode and cathode. So, if I look it in the clockwise direction, this will be gate, this will be anode, and this will be cathode. GAK they call it, gate, anode, cathode. Now, again there is a check that this anode has to be the body. So, if I test between this terminal, the middle terminal which is anode, and the body which is this metal portion, if I check between these two, the multimeter will show its continuity. So, these are the methods for metallic pack and for plastic pack to know the terminals of an SCR. Now, this is, since it is universal and standard method, you can always be sure that there cannot be anything wrong in selecting the terminals. In many times you will find that such type of SCRs are available, plastic pack especially, where anode, cathode and gate are printed. So, you are rest sure that the terminals selected like this cannot be wrong. Now, one thing very important about an SCR is, because it is a 4-layer device and you have to connect it in a circuit, there are 3 terminals, you have to be very sure whether the device is healthy or not. So, what could be the fault in an SCR? it can be short, it can be open, or it can be healthy. If it is short, very well known that if I find out the resistance between G and K, you have seen that anode and cathode, the extreme terminals had 3 layers, so it will give you very high resistance. But between G and K there is only one barrier, so resistance will be lesser. So if it is short, then we will find out the resistance between G and K, and the resistance will be 0. If it is open, again between G and K the resistance will be very, very high, say infinite. And if it is not short, if it is not open, very correct that it has to be healthy. Okay? So we can always find out these tests we can perform with the help of a multimeter, and we can find out whether the device is healthy or not. Now I will request my colleague Mr. Singh to perform all these tests on a multimeter. This is a metal pack SCR. He is going to test between gate and cathode. The meter is showing some resistance. Reverse it please. Again the meter is showing some resistance, it means the SCR is healthy. Now for the second type of metal pack SCR, again between gate and cathode, here the meter is showing some resistance. Reverse it please. Again it is showing some resistance, it means the pack is alright. Now for the plastic pack, this is the plastic pack, again between gate and cathode, the meter, the range is to be changed, yes, and the meter is showing some resistance. You can reverse it please. Again the meter is showing some resistance, it means it is a healthy SCR. Here you can also find out the continuity between the anode and the body. Yes, it is showing continuity, that means this is a healthy SCR. Now we can also check some of the damaged components. Here he is checking between anode and cathode. It is showing short, and anode and cathode it is showing open. It is showing open. So it is a very, very damaged component. Another component can be checked. This is between gate and cathode. It is showing short, 0 resistance. But between anode and cathode also it is short. Okay, thank you. Now before I go to the next component, that is Diac, I would like to explain you an electrical circuit with the help of which you can also test the health of an SCR. The circuit is like this. A very simple circuit. This is anode, this is cathode, and this is, say, gate. Now through a limiting resistance, I can give a supply to the gate. Okay? I have put a switch, that means when I close the switch the supply will be given here. The anode and cathode are permanently connected. This is an electric bulb, and a single phase supply is given here. This is a limiting resistance, and it is very important to limit the current which is going to the gate, otherwise you are going to damage the device. Now in this connection what will happen? When I connect it between anode and cathode and the switch is put on, that means the gate is also connected, the circuit should be completed, this device should conduct and the bulb should glow. That shows the device is healthy. Suppose on connecting this and putting this switch on, the device does not conduct, the bulb will not show any glow, that means the device is open. And there could be another condition, when I connect it between anode and cathode, I have not connected the switch, yet it glows, the bulb glows, that means the device started conducting. What does it mean? It simply means the device is short. So, a very simple electrical circuit with the help of which you can test the health of an SCR. Now, same circuit can also be tried when I go later in case of a triac, that can also be tested with the help of this circuit. Okay. So, this finishes the first part, that is the SCR. Now, I would like to take up the second very important component, which is Diac. Here you can see these small components, they are all Diacs. So, what is a Diac? You remember that SCR was a 4-layer 3-terminal 3-junction device, semiconductor device, but Diac is only a 2-terminal device. It is also a 4-layer semiconductor device, but there are only 2 terminals and we call them main terminal 1 and main terminal 2. Now, can you find the difference between SCR and a Diac? In case of an SCR, you remember it is a unidirectional device. Here I have put 2 arrows, one arrow in this direction, the other arrow in this direction. It means the conduction can be from this terminal to this terminal, also from this terminal to this terminal. This shows that it is a bidirectional device, and I can say that it is a 4-layer bidirectional 2-terminal semiconductor device. Now, since gate is missing here, I would say that it is not a control agent, it is not a control device, it is only used for triggering the SCRs or Triacs. Triggering means to conduct the device, and I can also say that Diac is nothing but a triggering agent. It is used for triggering Triacs, SCRs and so forth. Now, in case of a Diac, it is very simple to connect it in a circuit, because there is no difference between main terminal 1 and main terminal 2. Only thing is you have to know whether it is healthy or not, and its health cannot be checked with the help of a multimeter. Why? Because the device is going to only conduct where a particular supply has been given between M21 and MT2. That is known as the breakover voltage. It is written as VBO, and the commonly found Diacs in the market have a VBO rating from 28 volt to about 32 volt. Now, unless you give 28 volt to 32 volt across the 2 terminals, it is sure that the device is not going to conduct, and that is why I told you earlier that the device cannot be tested with the help of a multimeter, because multimeter gives you a supply of about 9 volt or so. Hence, you need not bother about its health, and you can test it directly in a circuit, but the terminals you need not identify also. Any terminal could be MT1, any terminal could be MT2, because it is going to be used in an AC circuit. In positive half cycle, this is MT1, this is MT2. In the negative half cycle, this becomes MT1 and this becomes MT2. So, that is all about Diacs, and now I go to the very important component, that is the Triac. Now, you will find here that the Triac is only found in the plastic pack. Look here, this is only plastic pack, and there is no metal pack in case of Triacs. Let us see what is a Triac. Triac looks like this. 3 terminals coming out, and this is the plastic pack. That you remember, it looks like a plastic pack SCR, and there were also 3 terminals. Here also you have 3 terminals. Now how will you find out the terminals? How will you identify the terminals? Suppose this is the triac. Again you will keep this printed portion in front of you and look clockwise, terminal 1, terminal 2, terminal 3, and it will be G, that means gate, T2 and T1. T2 means main terminal 2 and main terminal 1. We call them T2 and T1. G, T2, T1, of course clockwise. Oh, it is a standard rule and you have to accept it. It is universally taken, and this is, there is no problem in taking the terminals if you identify like this. Okay. Now here also in case of triac you have to be very sure whether the triac is healthy or not. It can be open, short or healthy. Again we can check it with the help of a multimeter. Now what will you check? You have to check the resistance between G and T1 because this stands for anode. If I compare it with SCR, I will say if SCR, say SCR has terminals as G, A, K. In case of a triac, the terminals are G, T2 and T1. So G stands for G, A is replaced by T2 and K is replaced by T1. So there I was checking resistance between G and K all the time. Here I will check resistance between G and T1. If the resistance is shown 0, that means it is short. If the resistance is very, very high, say infinite, it is open. So like that we can test it with the help of a multimeter. Again I will request Mr. Singh to demonstrate them on a digital multimeter. Now he is going to test a triac with the help of a multimeter. He is connecting it between G and T1 and the multimeter is showing some resistance. You can reverse it please. Again it is showing some resistance. It means the triac is healthy. Now some of the damaged components can also be checked. Here is one damaged component and is checking it between anode and cathode. It is short. 0 is coming, 0 resistance, which means that means it is short. Okay. Now between gate and anode it is all right. That means this device is particularly the anode and the cathode are short. There is one damaged triac and he is connecting it between T2 and T1, between T2 and T1, and it is showing 0 resistance. You see, that means T2 and T1 are short. Can you check it between G and T1?
Yes.
Please. So G and T1 is okay. You see, G T1 is okay, but T2 and T1 were short. Okay, thank you. Now I will also like to explain the electrical circuit which I explained in the case of SCR. The circuit is same as I said. There is a limiting resistance here, a switch here, anode, cathode, SCR. Now I am going to replace this thing by a triac. So anode will be replaced by T2, cathode will be replaced by T1 and gate remains as gate. In this case also, if I give a pulse at the gate, the device should conduct and the bulb should glow. If I do not give a supply to the gate, it should not glow. But if I have connected it like this and not given the gate supply and it starts glowing, that means the device is short. Again, if I have connected it in this fashion, given the supply also to the gate, again the bulb is not glowing, that means the device is not conducting, it means the device is open. That is true. But sometimes suppose this print, it has gone faded. So it will look like an SCR or triac also. You cannot identify which one is Triac, which one is SCR. For that also this particular circuit is going to help you. You can identify a plastic SCR, plastic pack SCR and a plastic pack Triac with the help of this same circuit. Now what do you think? If I put an SCR here and see the glow of this lamp, since it is a unidirectional device, only half wave will be obtained, so the glow of the bulb will be lower, intensity will be lower. And in case of Triac, since both directional, both the halves will be there, so the glow will be more. This also we can verify with the help of the particular circuit we have calibrated. So the same circuit has been rigged on a breadboard, and he is going to give a supply of how much? 200 volts? 200 volts is going to give, and first we are going to check SCR. He is giving the pulse at the gate, and here you see the bulb is illuminating and the reading is about 102 volts, so 100 volts. Okay. Now we can replace the SCR with the help of a Triac. Replace it please. Again give the same voltage, that is 200 volts, and change it to AC because it will give you AC output. Now he is going to give the pulse at the gate, and you see in this case the illumination is much more and the multimeter is also showing about 221 volts. So in this experiment we have verified two things. Number one is we have seen the health of two components, that is SCR and Triac, and both were found healthy. The second thing what we saw was the distinction between the SCR and the Triac. Now we are going to discuss some of the numbers of the SCRs and Triacs and Diacs which are normally found in the market. In case of SCRs we have OE506, OE806, SN104, KH6004, TYN6004. Now first three of the SCRs, all these are metal pack SCRs, and this is meant for 5 ampere 600 volts, this is 8 ampere 600 volts, this is 1 ampere 400 volts, and these two are plastic pack SCRs, they are 4 amperes and 600 volts rated. Now in case of Triacs we have 8044, 8064, 8136. They are all plastic pack Triacs and they are all meant for 4 amperes 600 volts rating. And in case of Diac you have DB3, this is the most commonly found Diac in the market. It has a breakover voltage of about 30 volt. So friends, in this part of the program we have discussed the thyristor components, that is SCRs, Triacs and Diacs, and in the next program we are going to discuss about the general purpose ICs. Thank you.